Hello and welcome again to our series of mathematics lessons. We have been looking at the topic right-angled triangles. We have been able to look at different subtopics on this particular topic. That is, we have been able to look at the Pythagoras theorem. We have been able to see how this Pythagoras theorem can be used to solve different problems, like getting the different sides of a right-angled triangle, and also in solving 2D and 3D problems. We have also looked at the trigonometric ratios. Where we said there are three basic trigonometric ratios in this particular topic. That is the sine, cosine, and tangent. We were able to give the ratios for those particular three trigonometric ratios, where we said that in any case, sine of an angle, theta, is normally given by the opposite divided by the hypotenuse of that particular side. Cosine, or the cos of an angle, will be given by the adjacent divided by the hypotenuse of that particular right angle triangle. And finally, tangent of an angle is normally given by the opposite divided by the adjacent side of that particular angle. And in short, we summarized all this information into one. That is, if you want to get sine, it is opposite all over hypotenuse. If you want to get cosine, it is adjacent all over hypotenuse. And if you want to get tangent, it is opposite all over adjacent. Again, it is important to note that if that is our right angle triangle, then that is angle theta, that is 90 degrees. The opposite to this angle will be this side. The adjacent to this angle will be this side, and the hypotenuse will be that particular side of the triangle. So in this lesson, we want to introduce and see how we can be able to use trigonometric ratios to solve denominators of a given function or equation. Solving for the denominator. Now, if you're given any fraction a over b, a is normally referred to as the numerator to this particular fraction, and b is referred to as the denominator of that particular fraction that is in question. We are going to use the right angles and the trigonometric ratios to be able to find the third side, or the denominator, or the pronumeral, or the unknown term in a given function or equation. Like, for instance, if you are given that x over 5 is equals to the sine of 30 degrees, for example, we can be able to obtain the value of x by multiplying both sides by this value, which is 5. So in this particular case, if you want x, you'll multiply both sides by 5. That means that your x shall be equal to 5 multiplied by the sine of 30 degrees. So we had said that for you to be able to use the calculator in finding the sine, cosine, and tangent of angles, then you need to reset your calculators to what we call the degree mode. So we look for the sine of 30, which is 0.5, and you multiply by 5. That will give you your x to be 2.5 units. Now again, depending on the position of that pronumeral on the sides of that particular triangle, you can be asked to find that particular unknown, or the pronumeral. Like in this case, if this is a right angle triangle, that being 30 degrees, that being x degrees, and this one being 5 degrees. Then you are told that you obtain the cosine of this particular angle, which is 30 degrees. We understand that cosine is normally given by adjacent all over hypotenuse. That means that the cos of 30 degrees will be equivalent to the adjacent, which is 5, divided by x. Now in this case, you discover that x is now a denominator of this particular fraction 5 over x. We can be able to get that particular value, or x, by first eliminating it from the denominator. And for us to be able to eliminate x from the denominator, that means you must multiply both sides by x. When you multiply both sides by x, you'll get x cos 30 degrees is equals to 5. Now finally, for you to be able now to get x, because now on the left hand side we have x cos 30 degrees, then you have to divide through by cos 30 for you to be able to obtain the value of x, and therefore we divide both sides by cos 30 degrees, and therefore for you to be able to get the denominator, you take 5 all over the cosine of that particular angle that you had been given. Let's look at several examples on how we can be able to solve the denominator. Example 1, we are told solve for x in each of the following equations. Correct 2 decimal places. Part A, we have 7 is equals to 15 divided by x. Now for us to be able to obtain the value of x, we have said we need to eliminate it from the denominator. And for us to be able to eliminate x from the denominator on the right hand side of the equation, we need to multiply both sides by x. So we multiply the right hand side with x. We also multiply the left hand side with x. X and x will cancel on the right hand side, and 7 multiplied by x on the left hand side will leave us with 7x is equals to 15. And therefore, for you to be able to get the value of x, we need to divide again both sides by 7. So we divide both sides by 7 for us to have x on the left hand side being equal to 15 divided by 7 should be 2.142857 So we get that particular quotient, it is 2.142857143. Always remember to go back to the equation. The equation is requiring us to write our answers correct to 2 decimal place. So to 2 decimal place, the value of x will be 2.14 units. Part B, we have cos 35 degrees is equals to 2 all over x. Again, recall that x is a denominator, and therefore we need to eliminate it from the denominator. And for us to be able to do that, we said we multiply x on both the right hand side and the left hand side. That will give us cos of 35 degrees is equals to 2 all over x. We multiply the right hand side with x, also the left hand side with x. X and x will cancel on the right hand side, leaving us with 2. And therefore on the left hand side we shall have x cos 35 degrees is equals to 2. Now for you to be able to get the value of x, we need to divide both sides by the cosine of 35 degrees. That is all over cos 35 degrees all over cos 35 degrees. And therefore, this and that will cancel on the left hand side, leaving us with x. So x will be equivalent to 2 divided by the cosine of 35 degrees, which will leave us with 2.44154917 units. Again, according to the question, we are required to write our answers correct to 2 decimal place. That means that our x shall be equal to 2.44 units, that is to 2 decimal places. Next example, example 2. We are told to find the value of the pronumeral correct to 2 decimal places. Part A, we have a right angle triangle, that being 90 degrees. This angle we are given 35 degrees. The opposite to the angle is 5 units, and then the hypotenuse is x units. We are supposed to evaluate or find the value of this particular pronumeral. Pronumeral, we had said, is that particular unknown alphabetical letter. Now, for us to be able to get the value of x, we need to know what is the relationship of x and the given 5 to this particular angle. You'll discover that 5 is the opposite to the angle, and x is the hypotenuse of that particular angle. And therefore, we're going to use a trigonometric ratio that has an opposite and hypotenuse out of the 3. So, toa. That means we use sine or trigonometric ratio of sine. That means that our sine of 35 degrees shall be equal to the opposite, which is 5 all over x. Again, you find out that x is in the denominator, and therefore we need to eliminate it from the denominator by multiplying both sides by x. When you multiply both sides of this particular equation by x, you'll get x sine 35 degrees is equals to 5. Now we have x sine 35 degrees is equals to 5. Our main aim is to find the value of x. Therefore, we need to divide both sides by sine of 35. That will be x sine 35 is equals to 5. We divide both sides by sine of 35, sine of 35. That will cancel, leaving us with x. So 5 divided by sine of 35 will give us 8.717233978 units. The question requires us to write our answers correct to 2 decimal place. That means that our x shall be 8.72, that is to 2 decimal places. So the most important thing is for you to know this relationship. If it is opposite, you have been given opposite and you need hypotenuse, then we use sine, or vice versa. And if you are given or denied either of the adjacent and hypotenuse, we use cosine. And if you are dealing with opposite and adjacent, then we make use of tangent. Part B of the same question, we have a right angle triangle where this side is 19 units, this side is x, this side is y, and we have been given 28 degrees. Discover that in this case we have 2 pronumerals that we need to find out. We need to get what x is, we also need to get what y is. for us to be able to get x, it is important to know what is the relationship that does x and 19 hold to this respective to this particular angle 28 degrees. You'll discover that 19 is the opposite side of this particular angle and that x is the adjacent. Therefore, we have two things in place, opposite and adjacent. So that means for us to get x, we need to use tan of theta is equals to opposite all over adjacent. That is, the tan of 28 degrees will be equal to the opposite, which is 19 all over x. We need to get the value of x, so we multiply both sides by x. That will give us x tan 28 is equals to 19. And for you to get the value of x, we divide both sides by tan of 28 degrees. That will give us that x is 19 all over tan 28 degrees. That will give us that x will be 19 divided by tan 28 degrees will give us 35.73380284 units. We write it to 2 decimal places as required by the question, so that will be 35.73 to 2 decimal places. We also need to get the value of y. So again, we need to know that y in relationship to this particular angle will be the hypotenuse of this particular triangle. And given that this is the hypotenuse and you have been given that as the opposite, then we need to use a trigonometric ratio that has opposite and hypotenuse. And in that particular case, we don't have a trigonometric ratio that uses the opposite and the hypotenuse. That means we must make use of the opposite and what? The adjacent. That means we are going to use tangent. And therefore, tan of 28 degrees shall be equal to, we must use, for us to be able to get the value of y, we must use the one that has hypotenuse and adjacent. And because already we have adjacent as 35.73, we can be able to get our y. That means we are going to use cosine of this particular angle, so that we use adjacent and hypotenuse. And therefore cos 28 degrees shall be given by the adjacent, which is x, and x was 35.73, corrected to at 2 decimal places, divided by the hypotenuse, which is y. Now for us to get the value of y, we multiply both sides by y, which will give us y cos 28 degrees is equal to 35.73. And therefore, for us to be able to get the value of y, we divide both sides by cos of 28 degrees. Therefore, y shall be equal to 35.73 divided by the cos of 28 degrees. That one will give us 35.73 divided by cos of 28, which will be equal to 40.47 units. A kite is flying at a height of 27 meters above 27 meters above the anchor. Above the anchor point. if the string is inclined at 42 degrees to the horizontal, we are supposed to find the length. Of that particular string correct to the nearest meter. Now we are having a kite that has been inclined to some string. So this is our kite being inclined to some string. We have been told that the angle made by that particular thread or the string with the horizontal is 42 degrees, and that the height from this particular point to that particular point is 27 meters. We are supposed to use trigonometric ratios for us to be able to find the length of this particular string. Let us call it x. We had said that for us to be able to obtain the unknown or the pronumeral in this particular case, we need to understand the relationship of that particular pronumeral to the angle that you have been given. Like in this particular case, x is the hypotenuse of this particular right angle triangle that is formed by the horizontal and that particular string that is supporting that particular kite, and therefore this is the hypotenuse. And the side that you have been given 27 meters in relation to that to angle 42 is the opposite, and therefore we must use a trigonometric ratio that has a hypotenuse and an opposite. And in that particular case, we shall use nothing other than the sine. Therefore, sine theta will be equal to the opposite all over the hypotenuse. Our angle is 42 degrees, so 42 degrees is equals to the opposite to this angle, which is 27 meters, divided by the hypotenuse, which we do not know. We call it x. For us to get the value of x, we need to multiply both sides by x, and that will give us x sine of 42 degrees to be equal to 27. For us to get the value of x, we need to divide both sides by sine of 42 degrees, and therefore x shall be equal to 27 divided by the sine of 42 degrees. From your calculator, 27 divided by sine of 42 will give us x to be 40.35 meters. But the question requires us to write our answer correct to the nearest meter. 0.35 has not reached a half of a meter, and therefore x shall remain to be 40 meters, correct to the nearest meter as required by the question. So important, always know the relationship of the side you are looking for with that particular angle. Then look at the side that you have been given, and then choose out of the three trigonometric ratio which one you are going to use to simplify your work. So example 3, a paraglider flying at a height that is flying at a height of 27 meters above the anchor, that is flying at 27 meters above the anchor point. If a paraglider flying at a height of 800 meters descends at an angle of 12 degrees to the horizontal. How far to the nearest meter has it traveled descending to the ground? So we have a paraglider that is descending to the ground, making an angle of 12 degrees to the horizontal line, and you have been told it was flying from the height of 800 meters above. The angle made is 12 degrees. We are supposed to get this particular distance that it will travel from this particular point to this particular point as it descends down. So we need to understand that the relationship of x to this particular angle made is the hypotenuse, then that is the opposite of that particular angle, and therefore going to make use of the trigonometric ratio of sine. And we understand that sine of theta is normally given by the opposite divided by the hypotenuse. And the sine, the angle in question here is 12 degrees. So sine of 12 degrees will be equal to the opposite, which is 800 meters, divided by the hypotenuse, which we do not know. We call it x. X is in the denominator, and therefore we can be able to solve it by multiplying both sides by x, which will give us x sine 12 degrees to be equal to 800. And therefore, for us to get x, we need to divide both sides by sine of 12 degrees. That will mean that x will be equal to 800 divided by sine of 12 degrees. From your calculator, when you divide 800 by the sine of 12 degrees, you will get that x is 3,847.74 meters. The question requires us to write that particular distance to the nearest meter, and because 0.78 is above 0.5, then we can be able to round it off this figure to 38.48 meters, and therefore we can be able to say that the paraglider has glided, or it has descended down for 3,848 meters. So that is how we can be able to use the trigonometric ratios in solving for the denominators. We want to proceed on and look at how we can be able to find the unknown angles by making again good use of the trigonometric ratios. Finding unknown now, whenever you are given a right angle triangle, that being 90 degrees, we can have that as theta. Then this will of course be your A, your C, your A, and your B. We can be able to find this angle theta by using trigonometric ratios. But before we proceed to that, it's important for us to understand how to use the calculator in finding the inverses of the three trigonometric ratios. Like for example, if you are given that sine theta, sine of an angle theta is equals to a third, for example. How do we get that particular angle theta? Now in this particular case, you see the sine of theta is a third. That means when you are reversing, you need to get the sine inverse of that particular ratio that you have been given. For you to do that, we need to get what we call the sine inverse. It's normally denoted with a small dash with 1 of 1 over 3. And that will give us our angle theta. So what you need to do, from your calculator, we normally press shift, then you press the sign to give you this particular sign. That is sine bar 1 multiplied by or of 1 over 3 will give you that particular angle. So a third, it will give us that our angle theta will be 19.47 1 to 20 63. This one can also be written as 19 degrees. When you press the degree, when you use the degree mode, it will give you 19 degrees, 28 minutes, and 16 seconds in that particular case. Example. Find the value of theta to the level of accuracy indicated. 1, we have been told that sine of theta is equals to 0.3907, and the nearest accuracy indicated is nearest degree. So what you need to do, we need to get the sine inverse of that 0.3907 to give us the angle theta. 3907 will give us that particular angle. So again, you press the sine inverse of 0.3907 from the calculator. It will give you that theta is 22.99806246 degrees. But you've been told to write it off to the nearest degree, and therefore the nearest degree here will be 23 degrees because 9 is more than 5. Part B, tan theta is equals to a half, and here to 1 decimal place. We're supposed to write it off or to approximate it to 1 decimal place. So again, for this case, for us to be able to get the theta or the angle theta, we need to get the tan inverse of 1 over 2 or a half, and therefore the tan inverse of 1 over 2 will be 26.56505118 degrees. And because the question requires us to write off to the nearest 1 decimal place, then that shall be 26.6 degrees. Because 6 is more than 5, it's going to affect this one to become 6. Example 2, the value of theta to the nearest minute, we are given a right angle triangle with the hypotenuse being 10 units and the opposite to this angle being 6 units. We need to find this angle to the nearest minute, and because the values that have been given, that is 10 and 6, 10 is the hypotenuse to this particular angle and 6 is the opposite to this particular angle. Therefore, we need to use a trigonometric ratio that has opposite and hypotenuse, and therefore from SOHCAHTOA we can be able to use sine to get this particular angle, and therefore sine of theta shall be given by opposite all over the hypotenuse, and in this case the sine of theta will be given by the opposite, which is 6, all over the hypotenuse, which is 10. So that means that sine of theta shall be equal to 6 over 10 is 0.6. For us to be able to get the value of theta, we need to get the sine inverse of 0.6, and therefore theta shall be given by the sine inverse of 0.6. That means that our theta shall be 36.8699 degree, which is almost the same when converted to minutes and seconds as 36 degrees 52 minutes and 11 seconds. The question requires us to write it off to the nearest minute, so we must consider these seconds. Because they are not more than 30, then they are not going to affect 52 minutes, and therefore we are going to remain with 36 degrees and 52 minutes. We need also to convert these 36 degrees to be in total minutes, and we had said that 1 degree is equivalent to 60 minutes. Therefore 36 degrees to minutes we multiply by 60, that shall be 2160, plus 52, it shall be 2212 minutes, that is to the nearest minute. Example 3, we are told that Adam who is 1.8 meters tall, 1.8 meters tall, holds up a plank of wood, a plank of wood 4.2 meters long. Find the angle, find the angle that the plank, find the angle that the plank makes with the ground. That the plank makes with the ground, correct 1 decimal place. So we have the plank of wood that you have been told is 4.2 meters. We are supposed to get the angle it makes with the ground, given that the man holding it is 1.8 meters tall. That is, Adam is 1.8 meters tall. Now, for us to be able to get this angle that is made by the plank of wood with the ground, we need to understand the relationship of 4.2 meters and 1.8 meters in relation to this particular angle. Now, in this case, 1.8 meters is the opposite to the angle, and 4.2 is the hypotenuse of this particular triangle, and therefore we are supposed to make use of a trigonometric ratio which has opposite and hypotenuse. And in that particular case, we are going to use again sine, which is opposite all over hypotenuse. And that will give us that sine of theta, which we are looking for, is equivalent to the opposite all over the hypotenuse. And therefore the sine of theta shall be equal to the opposite, which is 1.8 meters divided by 4.2 meters. 1.8 divided by 4.2 will be 42857, and therefore for us to get theta we must get the sine inverse of 1.8 all over 4.2. That one will give us that theta shall be 25.3769 meters, degrees. It will give us 25.3769 degrees, and we have been told to write it correct to one decimal place. Therefore the angle made will be 25.4 degrees. That is the angle that will be made by this plank of wood with the horizontal or the ground. The final question or example we want to consider on how to use trigonometric ratios in finding the unknown terms is example 4. We are told that for example 4, a children's sliding call it a slide, a children's slide, has a length of 5.8 meters. The vertical ladder is 2.6 meters. Is 2.6 meters above the ground. Above the ground. Find the angle. Find the angle the slide makes with the ground. With the ground correct to the nearest minute. Now this is another application area on how we can be able to use the trigonometric ratio to find that particular unknown angle. We have been told that there's a climbing stand, then the slide. We are told that this climbing ladder, which is normally vertical, is 2.6 meters, and then the slide itself is 5.8 meters. We are supposed to make or to calculate this particular angle that the slide makes with that particular ground. We again need to understand that the two given sides are relating to this angle, in that this will be the hypotenuse of the angle and this will be the opposite side of that particular angle. And therefore a trigonometric ratio that can be used to be able to solve this question is again sine. That is, the sine theta will be given by opposite, which is 2.6 meters, divided by the hypotenuse, which is 5.8 meters. And for us to be able to get the theta, that means we must get the sine inverse of 2.6 divided by 5.8. It will give us the angle theta. That means that the angle theta shall be 2.6 divided by 5.8, then you get the sine inverse of the answer shall be 26.63311.875 degrees. But when you press the degree, or when you use the degree mode, it will give us that theta is equals to 26 degrees, 37 minutes, and 59 seconds. 59 seconds. Now, because 59 seconds is more than 30, more than a half of a minute, then it's going to interfere with those particular minutes, and therefore 59 degrees can be able to be, will add 1 minute to 37 to make it 28, and therefore to the nearest minute that particular angle shall be 26 degrees and 38 minutes. So that brings us to the end on how we can be able to find the unknown angles, and also how we can be able to find the unknown sides when we make use of the trigonometric ratio. Another important aspect maybe to mention on the viewing angles. I like to mention something on viewing angles. If we have this particular point, and if you are this particular tower, for example, and you want to observe an object that is beneath you or on the ground, then if those are your eyes, then your eyes are going to make some particular angles with that particular object. And in this particular case, you must be able to draw the normal to this particular point of view. If this is the viewing side, then this angle formed here is normally called angle of depression, or the depression angle. And if it was the opposite, you are here and you want to observe somebody at the top of the building, then this will be your normal, and the angle made is this one. This angle is normally called the angle of elevation. Important to note that angle of elevation is always equal to angle of depression. That brings us to the end of our subtopics today. Thank you.